Integration with ECAD for electrical systems design. There's a lot of activity. Why is it happening? All right, so there's a lot of activity around integration between electrical CAD or ECAD for electrical systems design. And when I say electrical systems, I mean cabling, wiring, harness, not board systems design. So there's a lot of integration activity right now between the ECAD tool with system engineering tools and mechanical CAD tools. So what's going on there exactly? So if you look at the system engineering space, Zuken acquired Vitek. Vitek is a system engineering solution provider, model-based system engineering solution provider. Zuken provides ECAD tools for both electrical system design and board systems design. If you look at Capital from Mentor, which was just acquired by Siemens a little while ago, that tool actually has system engineering capabilities in it. But also they're integrating pretty closely with NX, which is the MCAD application from Siemens. You're also seeing a lot of activity around Solid Edge and Solid Edge Electrical, which comes over from the Mentor acquisitions as well. So what's the deal? Why is this happening? There's four main reasons that I think trends that are kind of driving this integration to ECAD for electrical systems design. So first off, there is increased complexity that companies are facing as they transition from traditional mechanical products to smart connected ones. And the skeleton for that to connect all these sensors, antennas, embedded systems with circuit boards. To connect all that up, you got to have an electrical system. And by that, the cables, the wires, the harness, all that stuff. So that's one trend. Another one is platform and modular approaches. So a number of different companies are moving the direction of platforms where they can increase the reuse of components and modules, but at the same time increase the variability or options that they have for variants for products. And if you're going to do that, you face an interesting challenge with electrical systems, because you can swap in and out different embedded software systems. You can swap in and out lots of different options. Do you have a unique harness for every single one of those? That's a major challenge. If you're removing major components, you don't want the additional weight of the harness that goes with the 110% product. A lot of companies don't see that as feasible. The next one is the third reason that's driving this is integration at systems test. A lot of companies are able to design within engineering domains in terms of a silo. Mechanical can go off and do their thing. Board systems can kind of go off and do their thing. But when you bring it all together, it has to work the first time. So that's really driving a lot of system engineering behavior. So you're defining interfaces, you're defining requirements, you're making sure it all works together at the end of the day. And you want that to happen the first time. We have some research explicitly that shows the more system level prototype failures you have, you are much less likely to hit design release. And that messes up the whole development schedule. That's the third thing. The fourth thing is there are a number of requirements, industry regulatory requirements that are coming out that that demand collaboration across disciplines. So there's an EWIS regulatory requirement that for aircraft you can't have the same signal. Redundant signals have to pass through different compartments of the aircraft, number one. And number two, there are certain compartments that the signals cannot pass through at all. So that means when you're routing your cables and your wires through the aircraft, for example, you have to keep that away from the fuel compartment. Number one. Number two, that signal, redundant signal, meaning you have two, can't go through the same compartment. So suddenly you have not just constraints on the logical and functional aspects of the harness, which you could handle in ECAD alone. Suddenly you have physical constraints on the design of these harnesses, and you have to have collaboration between MCAD and ECAD to make that work, because you got to know which signals are on which cables and wires. If you don't know that, you can't make sure that you are routing the two signals, the redundant signal, through different compartments, or that you can't have a certain signal go through a certain compartment like the fuel compartment. So as you can see, there's a lot of complexity going on with electrical systems today. It's being influenced by a lot of different trends, and that is what's driving the need for integration with system engineering on one front and mechanical CAD on another front. That's it. Take care. Talk soon.